You know what I think it is after a certain amount of time, it just shuts off.
So
I have to start it up again.
So you don't have to record your pocket all day.
So what am I going to do now? Yeah, I can separate it, but then I can make it nicer before I do that. I mean, to separate it right now, okay, I'm going to do that. I'll separate it for you right now. We're going to get powers of fractions. Joy, joy.
All right, I regret that. Never mind.
Can you just add the 2 over b to 0?
Yeah, that's what you should do. How do you add 2 over b to b over 2? You guys all do the high school algebra classes? Right? The common denominator of 2v, right? And then you cross multiply 4 plus v squared, but then it's going to get flipped over, right? So actually you're going to get the 2v is going to come out on top after you flip this denominator over. And on the bottom you're going to get 4 plus v squared, I believe. Everybody comfortable with that? Okay, and the right hand side, of course, is just dx over x. Now we've got it, you know, pretty well separated pretty nicely, right? This is kind of what we were shooting for.
Gotcha.
Now I've got a cameraman here. Okay, good. So, throw integral signs in front of both sides. And now, how do I do this first integral here? U-substitution, right? In fact, the derivative of the denominator, the derivative of 4 plus v squared is exactly 2v dv, which is what's on top. So this is literally just the integral of du over u, which is what? The natural log of whatever u was, which in this case, I'm going to just plug it right back in, 4 plus v squared. I'm going a little quick through the integration.
We don't need absolute values because v squared is always positive.
This is always positive. Right. So no absolute values are needed. Okay, and then what about on the right-hand side? ln, I'll put absolute value of x on that, and then plus c. So far, so good? Our job now is to hopefully come up with the same answer we did before. Let me come back over here. So what do I need to do next? Exponentiate this thing, right? Let's try to exponentiate this. Let's exponentiate it real quick. When I exponentiate the logarithm, I'm just going to get 4 plus v squared, right? And when I exponentiate on the other side, what am I going to get?
Absolute value of x plus c1.
Because that C1 is really e to the C, right?
Yeah. I'm not happy with it. Nobody's. I should have people complaining about this. Okay, let's back it up a little bit. Okay, isn't this just e to the ln of absolute value of x plus c?
Oh, yeah.
Just times, yeah. So it helps when you actually just write down the steps.
Yeah.
Okay, don't try and do it in your head. That's when mistakes happen, right? So this is e to the ln of absolute x times e to the c. And then e to the c is just c1, and e to the ln x is just absolute x. So that's the expression you're looking for. All right. Now I need to subtract 4. Basically, I need to solve for y, right? So I'm going to subtract 4. So I'm going to get v squared equals negative 4 plus c1 absolute x. Put the 4 on the other side, the minus. Okay? Now what?
Substitute back.
Right, substitute back. What's my substitution here? This is for homogeneous. Oh, I erased it. It's y over x. Okay, so this becomes y squared over x squared equals negative 4 plus c1 absolute x. And if I now put x squared on the other side, I'll get y squared equals negative 4x squared plus c1 absolute x times x squared. And I have to take the square root of both sides. So the square root is plus or minus the square root of negative 4x squared plus c1 absolute x times x squared. Is that the same thing? Pretty much. The same thing we got here, except I have an absolute value bar that showed up over there. If I just assume that x is positive, then everything's cool. Probably should just as well do that anyway. Yeah. Okay, so it's pretty much the same answer, right? That's pretty cool. Come by a completely different method. Whew, good. So by doing this problem both ways, we actually studied all 4 differential equations because the Bernoulli turned into a linear and the homogeneous turned into a separable. We sort of did it all. Wasn't that clever of me? One problem, all 4 methods.
All planned.
All planned out perfectly. There's one more problem on this sheet. Do you guys want me to do it? I will do it if you want me to. It's the mixing problem. Yes? No? It's up to you. I'm already over my time I said.
Is it similar to the one that you went over?
Oh, absolutely. Yeah, it's pretty much the same thing. As tank is half full, you know, so the tank has a volume of 200 liters and it's initially half full, and it's only 100 liters to start with. Right? Yeah, I don't think I need to go over it. The solution is very well typed up here. I shouldn't say that. I hope it's fairly well typed up that you guys can probably go through. It becomes linear, right? Mixing problems always become linear, so you have to do the whole integrating thing. You have to do the integrating factor and solve it. This time you have to solve for an initial condition too. It's always an initial condition on that. So I think what I'll do, I'll let you guys kind of play with that one, and you can always ask me about it anytime, tonight or tomorrow, and I'll answer as best I can. I'll be mostly around. I got to go to breakfast. Did I say that? Yeah, I did. So from about 9 until 11, I'll be having breakfast. So you can come over to the gastronome and catch me there if you're hungry.
What if we have questions?
Come over and ask me questions. Sure. No, but I'll be up to my office by 11, and I know that's a couple hours before the test. But I'm hoping I'm not going to get deluged with like a lot of major significant concerns, you know, right before the test, because that doesn't do you any good. That just freaks you out, right? It's okay to come and ask me questions, of course, but I'm hoping there'll be like details like, is this a typo in your solutions? Because there are a couple of those, and that sort of thing. Okay. Has this been helpful?
Yeah.
Sort of. I mean, at least if nothing else, it kind of gets the material back in your head, kind of all at once, which you can do.
Really quick, can we actually do the integral of the e to the negative?
E to the negative integral of 3 over x dx, I can absolutely do that. It's e to the negative, this is a 3, I'm going to pull it out.
Oh,
And the integral of 1 over x is just ln of the absolute value of x. And I'm putting 0, oh, that's where my absolute value of x was supposed to be. Anyway, so this is absolute value of x to the negative 3, right? Because the negative 3 goes up, and then e to the ln cancels.
gotcha.
I know, you need to make x positive, because otherwise you're going to end up having to integrate an absolute value function, which there is no simple antiderivative for.
But there is.
Well, it involves studying area. So if I want you to integrate the absolute value of x function from negative 1 to 2, the only thing you can do is build triangles and find the area. There's no analytic expression for it. So on a problem like this, I really should have said, assume x is greater than 0. I'm much more careful about those kind of things when I'm writing the test questions than I am when I'm just throwing together review problems. I will solve my exam before the exam. Some professors don't do that. And then they find all these problems in the middle of the test. I will make sure that I have debugged it and solved it all out and caught all those issues. So you guys hopefully won't have those issues.
You should just send it to us just in case. We can
You guys
check
will
your
catch
work.
my errors for me. Yeah. You guys are so helpful when the tests come around. I noticed that. Give me all kinds of good ideas.
Can you go through those problems that may have given us trouble on the other review papers that you gave out?
Yeah, I'm happy to do that.
Number 6. If you go to the board, maybe it's just.
Yeah, I'll throw it on the board real quick.
It makes it come to me.
Oh, you know what? It should have stumped you a little bit. It should have, because it's a little bit weird. So Zach is asking me about this problem in the review packet. X dy dx minus y equals x cubed over y e to the y over x. Okay, that equation turns out to be, yeah, it's none of the above in terms of our 4 types of equations. You can't separate it. It's certainly not linear because you've got an e to the y in there.
It's almost homogeneous.
It's almost
Homogeneous.
homogeneous.
Say it differently.
It's definitely not Bernoulli. And that the point of that problem is that yes, it is almost homogeneous. In fact, if you divide through by x and move things to the other side of the equation, you get basically this.
Just the x squared over y.
It's just that one little thing is not quite right about it. Otherwise, it would have been homogeneous. So the trick to that problem, and this is not something I would likely expect of you on a pressure test, but the trick is to go ahead and use the homogeneous substitution anyway. Even though it's not quite homogeneous, if you replace v with y over x, you're still going to greatly simplify the right-hand side. Right? So for example, y prime here is going to become what? Xv prime plus v. And then y over x is going to become v. And, all right, here's where you got the problem. There's an extra x on top. So x over v and then e to the v. Like that.
So I guess you could still.
So it's still going to work. These v's are going to cancel. And it is going to be separable. It is actually going to turn out to be separable. Let's just see if we can get it separated. If we rewrite the v prime as dv over dx, it equals x e to the v over v. So in separating, is that right? Oh, the x's actually cancel too?
Yes.
Oh my word! So the x's are actually gone as well. So it's actually just v e to the negative v dv equals dx. There you go.
Okay, that got a lot easier.
And this, of course, is easy to integrate. This one over here, you have to do integration by parts for.
That would be in the table of integrals, right?
You wouldn't ask us to do the test.
Or just don't give it to us.
Well, I did. That's a good question.
Because you did give us
Shouldn't I
that.
expect my 4th semester calculus students to be able to do integration by parts in this one?
Nope.
Yeah, but that's
Time-sensitive
too much
question.
work.
4th semester. Come on, you're killing me.
That's
It's
unnecessary.
It's unlikely that I would ask you, if I expect, okay, put it to you this way, if I don't give you the integration by parts formula and you do it wrong because you don't know how to do it, you're going to get, on, let's say this, and I wouldn't ask you this one anyway probably, but you would get 80%, maybe 90% of the credit just for getting to this point, because the last part of it really is just doing an integral, and that's not what Math 250D is about. This is not a course on doing integration. So, I mean, you can look at that 2 ways. Like either I can expect that you already know how to do the integration, and so we're just kind of not worrying about it, or I could just say, well, you're not responsible for it because that's not what we're covering here. But I mean, yeah, I mean the way this, you guys have done this before. I know you know how to do this. Oh, except that V is a terrible choice of notation. Because you usually use the U and V. Oh my gosh. All right, we better use different letters. W. DW would be V e to the negative V dV. And DU would be dV.
And you integrate that.
See, I can't even do it. E to the negative v dv, right? You put the v over there, and
Yeah.
e to the negative v here. So you integrate here, and you get negative e to the negative v, right? And then the formula for that then is u times w, so it's negative v e to the negative v minus the integral of this one times that one, which is actually plus e to the negative v dv. And so it's something like this. By integration by parts.
And then we have to.
Don't sweat it. Don't stay up all night reminding yourself how to integrate
The
something.
moral of the story, though, is that even if it does not look homogeneous at first, but it's really close, we could still
Yeah.
try that change of it.
Mm-hmm. The idea behind this is, yeah, it cleans it up, right? When you do v equals y over x, it just cleans it up immediately. Right? So that's the reason to do it. You're not doing it because it is homogeneous. You're doing it because it cleans up the expression. It's almost homogeneous. Make sense? Pretty good on all that stuff.